Next problem again is pretty straightforward, but there is a trick to the calculation. And that is if you label what you have, because you're dealing with a rhombus here, you know that these diagonals not only bisect each other as they do in all parallelograms, but they are perpendicular as well. And then you know that all of the sides are equal to each other. So if you label what you have, JK is 16, that means each of these side lengths is 16. JB is given as 8. And then in this case, we want to find BK is Y, and the expression for angle JBK, which we see here is a 90-degree angle, is given by that expression. So the first thing we can do is find x. If we take 10 times the quantity x plus 10 squared, set it equal to 90, and solve. Divide both sides by 10. And then extract your square root. And this is where the trick comes into play. Because when you extract a square root like this, you have to take into consideration the positive and negative root. So this is plus or minus 3. And now when you subtract 10 from both sides, plus or minus 3, what you wind up with is negative 10 minus 3 is negative 13. Negative 10 plus 3 is negative 7. So you are going to have two possible solutions for x. Okay, and then your y value you can solve using this right triangle here. We have, if you look at it 3, 4, 5, or 5, 12, 13, this hypotenuse is not a multiple of either 5 or 13, so we're not going to use the special triangles, so we can use Pythagorean theorem. Y squared plus 8 squared equals 16 squared. Subtract 8 squared from both sides, extract your square root. And again, here we can disregard the plus or minus because we're dealing with a length. The length can't equal a negative, so it's just going to be the positive version of that. And so if we take the square root of 16 squared minus 8 squared, we'll put a decimal in there so that we get an answer in decimal form. And I get 18 or 13.86 approximately. And if you left it in just terms of an exact radical, you get 8 root 3. So either of those forms would be acceptable.